So now we are going to deal with another topic called as that of your classification of units. Very much important. Okay, depending upon its name, we are going to see that how the lattice points are arranged in a particular units. So first one, it is called as that of your primitive units. Primitive units. Okay guys, so you have to just remember that in a primitive unit cell, of course we have come to know that what do you mean by a unit cell. Now we are going to say that in a primitive unit cell how the lattice points have been arranged. Okay, so you have to remember that in a primitive unit cell only the particles are arranged at the corner positions of your unit cell. For example, if I am writing like this as a unit cell, remember it is just a unit cell, a smallest part I have chosen. Okay, okay, in a primitive unit cell what happens, the lattice points or the particles are present only at the 8 corners, only at the 8 corners. So such type of a unit cell will be called as what? As a primitive unit cell. Is that clear? So a unit cell in which the particles are present only at the corners of the unit cell, only at the corners of a unit cell. Please, I am again and again repeating, it is about a unit cell and we are classifying a particular unit cell. The second most important classification we have to see, it is called as that of your centered unit cells. Centered unit cells, which is once again classified into two types. One is called as a body centered unit cell and another is said to be that of a face centered unit cell. Body centered unit cell and a face centered unit cell. Remember, in a body centered unit cell, if I am going to write a unit cell in this way, okay, so remember, in a body centered unit cell you will have the particles at the corners and also at the center of the unit cell. Able to understand? The particles are present at the corners and also at the center of the unit cell and center of the body. That is the reason it is called as what? As the body centered unit cell. Present at the corners and also at the center of the unit cell. Can you please now say what would be the face centered unit cell? Yeah, any idea? So here also your particles are present at the corners, of course. Along with that one, it is also present at the 6 faces of your cube. 6 faces of your cube. Alpha, totally there are 6 faces. Okay. So in the front you are having one face, so here also you are having one, and in the back side also you are having one face, so here also one. So totally there will be at the corners and also at the 6 faces of your cube. That is called as what? As a face centered unit cell. So what we have seen, primitive unit cell means a unit cell in which the particles are present only at the corners of the unit cell. In a centered unit cell where we saw we are having two types, body centered and the face centered. So in a body centered we have observed that the particles are present at the corners and also at the body centered, at the center of your unit cell. And in the face center we have observed that it is present at the corners and also at the center of all the 6 faces of your cube. So this is very much important when you are going to deal with certain derivations part in your later videos. We are going to see in a primitive unit cell only at the corners, body center at the corners and at the center of your unit cell, face center at the corners and also at the 6 faces of your cube. Now, as I mentioned earlier that with respect to the 6 parameters, we are going to have the unit cell with respect to 14 types depending upon your 6 parameters, which is called as set of your Bravais lattices. So let us deal by it with one by one. As I mentioned over here, depending upon your 6 parameters. The first important crystal system is your cubic system. So you know that cubic is a symmetric part. So in this type of a cubic crystal system, all the 3 types are also possible. That is, primitive can also exist, body center can also exist, face center also can exist. How can you say that a crystal system is a cubic with respect to its axial distance and the axial angle? So you can mention over here, as I said, your cubic is a symmetry. So you're having axial distance A is equals to B, that is equals to C. Coming with respect to the axial angle, here the alpha is equals to beta, that is equals to gamma, which all are equals how much degree? 90 degree. So when such axial distance or axial angles are present, the crystal system is called as set of your cubic system. For example, whatever the table salt we are using in our day-to-day life, NaCl belongs to the cubic crystal. Copper, your zinc blending, you can just see its composition in our metallurgy lesson, zinc blending. Okay, so these are the examples of a crystal which is having a cubic system. Able to understand? Which is having a cubic system. Now coming with another crystal system which is called as that of your tetragonal. Tetragonal, in which you are having the 2 variations. It can either exist in a primitive or also it can either exist in a body centered. How can you say it is a tetragonal? Depending upon its axial distance, we can just see that here A is equals to B, but B is not equals to C. Okay, and the axial angles, no problem. Here alpha is equals to beta, gamma, that is equals to 90 degree. So no problem with that. Here, but what is the change with respect to cubic? Here A is equals to B, but B is not equals to C. So such 6 parameters will be defining a crystal system called as that of your tetragonal. You could just take an example of your white tin, or that of your tin oxide SnO2, or titanium oxide, even that of your calcium sulfate. Even though you have not seen these 3, we have seen that of your calcium sulfate in our lab classes. You can just keep that one in your mind. So calcium sulfate is a crystal which is having a tetragonal system. Coming to the another class which is called as that of your orthorhombic. Orthorhombic. So here remember you are having primitive, body centered, face centered, and also the end centered. That is very much important. I will be dealing with it in the later class. What do you mean by end centered? So here what is the system? Here A is equals not equals to B, B is not equals to C, alpha is equals to beta, beta is equals to gamma, that is equals to 90 degree. Example is that of your rhombic sulfur, barium sulfate. We have seen this part. Potassium nitrate. So these are the examples of that of your orthorhombic. How can you say A is not equals to B, B is not equals to C, but alpha is equals to beta is equals to gamma, that is equals to 90 degree. Coming with respect to that of your hexagonal, in which the system can exist in a primitive only. That is, it is only having the lattice points only at the corners. So here what is the part? A is equals to B, B is not equals to C. And what about the axial angles? Alpha is equals to beta, which is equals to 90 degree. But gamma is not, but gamma is equals to 120 degree. Yeah. Example is that of your graphite. So whatever the pencil lead we are having in our pencil, so that will be having the shape of that of your hexagonal. We have seen now in our first PUC classes when we are drawing the hexagonal graphene sheets, they will be having an hexagonal crystal lattice. And that of your cadmium sulfide or zinc oxide, so they are belonging to that of your hexagonal crystal system, where you are having the axial angles as A is equals to B, B is not equals to C, and having the axial angles as alpha is equals to beta, which is equals to 90 degree, gamma is equals to 120 degree. The another crystal system is called as that of your rhombohedral, or it is also called as that of your trigonal. Here also you are just having the primitive part, okay, in which the axial distances are A is equals to B, B is equals to C, alpha is equals to beta, beta is equals to gamma, but gamma is not equals to 90 degree. Example is that of your mercury sulfide, which is called as that of your cinnabar, 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 or that of your calcium carbonate, which we have seen, alva. So these are the systems which will be having that of your rhombohedral or the trigonal crystal system. Coming with respect to the monoclinic, in which you are having the two types, primitive and also the end-centered. Here you are having the system as A is not equals to B, B is not equals to C, alpha is equals to gamma, which is equals to 90 degree, but beta is not equals to 90 degree. Example is that of your monoclinic sulfur. See, monoclinic. Example is also of monoclinic sulfur. So then Na2SO4, 10 water. Coming with respect to another class system, which is called as that of your triclinic, which is only existing in a primitive form. Here the actual distance A is not equals to B, B is not equals to C, and alpha is not equals to beta, beta is not equals to gamma, and that is not equals to 90 degree. Example of potassium dichromate, the orange color crystals what we have observed. Even the copper sulfate pentahydrate, the blue clear crystals. You have not seen this part, okay. So these are the crystals which will be having a crystal system of that of your triclinic. Very much important, because they can ask you any of these. Axial distance and axial angle will be given, and they will be asked you to write the crystal's name, or they may ask you the crystal name and they can ask you to write the axial angles of the axial distance. How to remember it? So remember that in a cubic, as I said, it is a symmetrical part. Alva. So symmetry means what happens? All the distances should be same. A is equals to B, B is equals to C, alpha is equals to beta, beta is equals to 1, that is equals to 90 degrees. So no matter. You have to remember this first part. Coming with respect to that of your tetragonal, what happens? We are just eliminating one part. A is equals to B, B is not equals to C. Can you just see tetragonal, orthorhombic and cubic all are having the same axial angle. So no problem. The first three name you have to remember in a sequence order. Then what happens? One has been eliminated out. In the orthorhombic, all the three are the eliminated out. In cubic, all were equal. In tetragonal, C was not equal. And in orthorhombic, all the three are not equal. If you have finished this one, then we'll be going with it hexagonal. So in hexagonal, what happens? Similar to that of your second one, you have to write first over here. That is A is equals to B, B is not equals to C. Then as soon as you are writing the second one, then in rhombohedral, you have to write as cubic system part. A is equals to B, B is equals to C, the first one. Then with respect to the monoclinic, the last one. A is not equals to B, B is not equals to C. Coming with respect to the axial angle, here there will be some variations. In the first case, say A and B are same. So what has happened? Alpha is equals to beta, that is equals to 90 degree. But C is not equal, which is gamma equals to 120 degree. Here all the three are equal, but what is happening over here? Here also all the angles are equal, but they are not equals to the 90 degree. In monoclinic, what is happening? All are not equal, but here what is happening? Alpha is equals to gamma, which is equals to 90 degree, but beta is not equals to 90 degree. So monoclinic and triclinic, you are having the same axial distances, but with respect to over here, triclinic, you can remember, see here all are not equal. Here also they are not equal. All are not equal to one another and also not equals to 90 degree. Now how to remember these names in a sequence? If you are remembering the names in a sequence, easily you can remember this part. So I have given you the hint. Corona targeted only highly rich, mad, foreign returns. You can just see my marked words. So cubic, the first one. T, what is called tetragonal. O, orthorhombic. H, hexagonal. R, rhombohedral or trigonal. M, monoclinic. So foreign I have just written, for my sentence should be in a proper way. In returns you are having the T, which is triclinic. If you are remembering this, you will be remembering in a proper sequence. You can easily write this axial distance and the axial angle part. Is that clear, guys? So this is the way I said that the 6 parameters. You can just see that how if the parameters are changing, we are getting a 14 types of a crystal lattice, which is called as the of your Bravais lattice. So in our next video, we are going to see that what will be the number of the atoms in a unit cell. Okay.